Sierra placed a new card on the table. Grams of hydrogen on one side, grams of water on the other.
Today the question looks simple, but the units are trying to skip steps.
It asks for grams, but our reaction ratio compares moles.
So we cannot jump straight from grams of hydrogen to grams of water.
That sounds like a shortcut with a trapdoor.
Very dramatic, very chemistry.
Shortcut rejected, unit map required.
Exactly, a stoichiometry problem needs a path.
First, grams of the known substance become moles of the known substance.
Then the coefficients compare moles of the known substance to moles of the wanted substance.
Then moles of the wanted substance become grams of the wanted substance.
So the map is grams, moles, mole ratio, moles, grams.
Yes, the mole ratio is the middle bridge, not the whole road.
Route saved, grams to moles, mole ratio, moles to grams.
The class arranged 5 cards in a clean line across the table. If we follow the cards in order, every number keeps its label.
That is the first lesson. Stoichiometry is not magic, it is a labeled path.
The first card on the map said grams of the known substance.
Our first job is not the reaction ratio yet.
First, we translate the given grams into moles.
That translation uses molar mass, the mass of 1 mole of a substance.
So molar mass is like a unit dictionary.
It tells grams how to speak mole.
Dictionary accepted, input unit, grams, output unit, moles.
For hydrogen, the molar mass tells us how many grams belong to 1 mole of hydrogen.
Then we can divide the grams by grams per mole.
The gram units cancel and the answer is in moles.
So we are not changing the substance, we are changing the way we count it.
Same hydrogen, new unit outfit.
Known substance remains known, unit changes from grams to moles.
Good, only after this first conversion can the coefficient ratio help.
Because coefficients compare moles, not raw grams.
The page is simple: known grams, molar mass, known moles.
The class moved the first marker from the grams card to the moles card.
Step 1 is complete when the known substance is measured in moles.
The marker now sat on moles of the known substance.
Good, now the reaction ratio is finally allowed to speak.
Because we are using moles, not grams.
The coefficients compare moles of 1 substance to moles of another substance.
So this is the middle bridge on the map.
Very official, bridge has opened.
Bridge condition confirmed, known moles entered.
To cross the bridge, choose the ratio that connects the known substance to the wanted substance.
If hydrogen is known and water is wanted, the ratio points from hydrogen moles to water moles.
The known substance goes on the bottom, so its mole unit cancels.
The wanted substance goes on top because that is the unit we need next.
Bottom cancels, top survives. That sounds suspiciously useful.
Known moles cancel, wanted moles remain.
Exactly, the coefficient ratio does not give grams yet.
It only changes which substance the mole amount belongs to.
So the second step is known moles to wanted moles.
The class moved the marker across the middle bridge without touching the gram cards.
Now we have moles of the wanted substance. The last step will turn those moles into grams.
The marker had reached moles of the wanted substance.
Good, we crossed the ratio bridge, but the question still wants grams.
So the last step is another conversion, not another ratio.
We use the molar mass of the wanted substance this time.
Because now the answer belongs to water, not hydrogen.
New substance, new unit dictionary. Very tidy.
Final conversion loaded, wanted moles to wanted grams.
Place the wanted molar mass so mole is on the bottom and grams is on the top.
Then the wanted mole unit cancels, and the gram unit remains.
So we are not changing the substance anymore, we are changing the unit back into mass.
Same water, different label.
The number comes home wearing grams.
Output confirmed, grams of the wanted substance.
Exactly, the first conversion got us into mole language, the ratio changed substances, and this conversion returns to measured mass.
That means the full path is finally complete.
Known grams to known moles to wanted moles to wanted grams.
The class traced the whole route across the cards one more time.
Now the map can answer gram-to-gram questions without skipping a single label.
The complete map stretched across the classroom table.
The route is correct, but the labels are what keep us from getting lost.
Each number needs a unit and a substance name.
So we write grams of hydrogen, not just grams.
And moles of hydrogen, not just moles.
A number without a label is a suitcase without a name tag.
Tracking sequence, grams hydrogen, moles water, grams water.
Notice where the substance changes. It happens only at the coefficient ratio.
The molar mass steps change units, but they keep the same substance.
Hydrogen stays hydrogen when grams become moles.
Water stays water when moles become grams.
Only the ratio bridge lets one substance hand the calculation to another.
Label check complete. Every transition has one clear job.
If a unit cancels, cross it out. If a substance changes, point to the ratio.
Then we can read the entire setup from left to right.
Known grams to known moles, then wanted grams.
The class added a label beneath every card on the map.
Keep the labels visible, and the path will tell you what to do next.
The labels were in place, and now the class tested every cancellation.
Unit cancellation is not decoration. It proves that the setup is moving in the right direction.
A unit cancels only when the same unit appears once on top and once on the bottom.
So grams of hydrogen cancel with grams of hydrogen, not with grams of water.
The unit matches and the substance must match too.
Same name upstairs, same name downstairs, then they may leave together.
First check, known grams divided by grams per mole leaves known moles.
Next, known moles cancel against the known moles in the coefficient ratio.
That leaves moles of the wanted substance.
Then wanted moles cancel against wanted moles in the final molar mass.
And grams of the wanted substance survive at the end.
The surviving unit is the answer's outfit.
Target check, the question asks for grams, and grams remain.
If the wrong unit survives, do not force the arithmetic. Turn the conversion factor around.
The units can diagnose the setup before we touch the calculator.
Cancel first, calculate second.
One by one, the crossed-out labels revealed a clean path to grams.
Careful cancellation makes the map check its own work.
The conversion path was ready, but Sira covered the calculator with one hand.
Before we calculate, let us predict the neighborhood of the answer.
Not the exact number, just a reasonable size.
We can round the molar masses and ratios to friendly values.
Then we ask whether each step should make the number larger or smaller.
The answer needs an address before it gets an exact house number.
Estimate mode active, round, compare, predict.
If 10 grams becomes about 5 moles, the first step made the number smaller.
If the coefficient ratio is 2 to 1, the next amount should be about half as many moles.
And multiplying by a molar mass turns those moles into several grams.
So an answer of 5,000 grams would not fit our estimate.
That calculator answer would be in the wrong neighborhood entirely.
Reasonableness warning, inspect decimal placement and conversion direction.
An estimate cannot prove the exact answer, but it can expose an impossible one.
It also helps us notice when a factor was flipped.
Predict first, calculate carefully, then compare.
The class wrote a rough range beside the map before entering any numbers.
A good calculation should land near the estimate and finish with the correct unit.
Sierra placed a fresh problem beside the map.
4.0 grams of hydrogen reacts with oxygen. How many grams of water can form?
Known substance, hydrogen. Wanted substance, water.
The balanced equation is 2 hydrogen plus 1 oxygen makes 2 water.
First, estimate a few grams of hydrogen should make a few tens of grams of water.
Our answer has a neighborhood. Now it may enter the map.
Step 1. Convert 4.0 grams hydrogen to moles hydrogen.
Use 2.016 grams hydrogen per mole.
4.0 divided by 2.016 is about 1.98 moles hydrogen.
The gram unit cancels and moles of hydrogen remain.
Now cross the coefficient ratio bridge.
2 moles hydrogen points to 2 moles water. A very balanced bridge.
1.98 moles hydrogen times 2 moles water over 2 moles hydrogen.
The hydrogen mole unit cancels.
That leaves about 1.98 moles of water.
We have changed substances, but we have not reached grams yet.
The marker stopped at wanted moles, one station before the answer.
Part 2 will use water's molar mass to finish the path.
The marker waited beside 1.98 moles of water.
Now we finish the final conversion from wanted moles to wanted grams.
Water's molar mass is 18.015 grams per mole.
Place grams of water on top and moles of water on the bottom.
Then the wanted mole unit has a matching partner to cancel.
Moles leave the stage. Grams get the final spotlight.
Calculation loaded. 1.98 moles water times 18.015 grams water per mole water.
The mole of water labels cancel above and below.
The only surviving unit is grams of water.
1.98 times 18.015 equals about 35.7.
That is close to our estimate of a few tens of grams.
Same neighborhood. No decimal disaster today.
Reasonableness check passed. Size and unit both match the prediction.
Now respect the original measurement. 4.0 grams has 2 significant figures.
So the final reported result is 36 grams of water.
Every conversion factor did one job and every unwanted unit canceled.
The class traced the completed route from 4.0 grams hydrogen to 36 grams water.
That is the full gram-to-gram map, calculated and checked.
Ben drew a tempting shortcut straight from hydrogen grams to water grams.
The coefficients are 2 to 2, so could 4 grams hydrogen simply make 4 grams water?
That arithmetic is neat, but the meaning is wrong.
Coefficients compare particles and moles. They do not compare grams.
2 moles of hydrogen and 2 moles of water have very different masses.
Same mole count, different luggage.
Unit mismatch detected. Grams cannot enter the coefficient ratio bridge.
Look at the labels. Grams of hydrogen cannot cancel with moles of hydrogen.
The setup itself warns us that the shortcut is broken.
First, use hydrogen's molar mass to turn known grams into known moles.
Then use the coefficient ratio to change hydrogen moles into water moles.
Moles may cross the bridge. Their paperwork is impeccable.
Finally, use water's molar mass to turn wanted moles into wanted grams.
The molar masses belong outside the ratio because they connect moles and grams.
The coefficients belong inside the ratio because they connect moles of different substances.
If grams appear in the coefficient ratio, stop and rebuild the path.
Ben erased the shortcut and restored both molar mass gates.
Never use grams in the mole ratio. Let each conversion do its own job.
The calculation was finished, but Sierra did not circle the number yet.
A number alone is not a scientific answer. Tell us what the number means.
36.
36 what? Raindrops. Sandwiches, extremely organized pigeons.
Begin with the quantity and unit, 36 grams.
Then name the wanted substance, 36 grams of water.
Identity confirmed. The formula is H2O.
Now connect the answer to the known substance and the balanced reaction.
4.0 grams of hydrogen can produce 36 grams of water.
Good. Add the condition that oxygen is available in excess.
That condition matters because hydrogen is the amount we started from.
No invisible ingredients, no mysterious number, no chemistry gossip.
Final statement: 4.0 grams of hydrogen can produce 36 grams of water when oxygen is in excess.
The sentence now carries the quantity, unit, substance, and reaction context.
And 36 has two significant figures, matching 4.0 grams.
That makes the answer both mathematically correct and scientifically complete. The class boxed the sentence, not just the number.
Finish every stoichiometry problem by writing what your answer means.
Mina rolled the entire stoichiometry map across the classroom floor. Every grams to grams problem follows the same route.
Start with grams of the known substance.
Use its molar mass to reach moles of the known substance.
Then use the balanced coefficients to cross to moles of the wanted substance.
Only moles may cross the coefficient ratio bridge.
Grams wait politely at the gates. Their bridge passes were denied.
Use the wanted substance's molar mass to finish in wanted grams.
Write every substance label and arrange the factors so unwanted units cancel.
Estimate before calculating, then check whether the result is reasonable.
Finally, round correctly and write a scientific sentence.
Complete route confirmed. Known grams, known moles, mole ratio, wanted moles, wanted grams.
5 stops, 2 gates, 1 bridge, and absolutely no teleporting.
Molar mass changes the unit between grams and moles.
The coefficient ratio changes the substance while keeping the unit in moles.
That is why the map works for many different balanced reactions.
I do not need to memorize a shortcut. I can rebuild the route from the units.
The map no longer looks long. It looks dependable.
Known grams to known moles across the mole ratio, then wanted moles to wanted grams.
Follow the units, trust the map.